Hello guys, today in this video I am going to explain the detailed mechanism for Baeyer villiger oxidation, and at the end of the video I will explain you one short trick also. With that short trick you can solve any problem related to this Baeyer villiger oxidation, and you can easily write the product without having any doubt. So without any further delay, let's get into the topic. If we see the example for this Baeyer villiger oxidation, let's see one example. With that I will explain you mechanism also. Here let's take R1C double bond O R2. Generally in this reaction ketones are oxidized in the presence of paracids like NCPBA, and you can say H2O2 or RCO3H. We can take any paracid. Paracid means in general acid have only two carbons, RCOOH. Here we are having three carbons. This is called paracid. You can remember like this. And let's see the example. Here R1C double bond O. Here you may get the doubt like why you add this, why you insert this oxygen here only. I am considering like R2 is more electron rich than R1. By this you can understand like more electron rich will migrate it. In mechanism I can say in detail. Let's see the mechanism first, then I will explain you this thing again. Let's see the mechanism. See, here we are taking this ketone R1C double bond O R2. Here we have this paracid RC double bond OH. So here this is acidic hydrogen. So it will up this. Here we have lone pairs on this oxygen. So this lone pairs will abstract this hydrogen. This bond will be shifted towards oxygen. Then you will get R1 R1C double bond OH. Here we will get positive because we donated this lone pairs to this hydrogen, so we will get positive on this oxygen, and then this one become RC double bond O minus. So after that this will attack on this carbonyl carbon, and this bond shifts towards oxygen. Then you will get R1C OH, and you can write this R2 here and then attack this OC double bond O R. Then after here this is the important step in this reaction. Here see here we have this lone pairs on oxygen. So this lone pairs will shift to this carbon, and this R2 group is migrated towards this oxygen, and this group will be removed, or this group will be removed from this thing. Let's see what we will get. R1 C double bond O H positive. Here we will get positive because here lone pairs due to this. Here it is making bond, so we will get positive on oxygen. And here we are migrating this R2 group. See here why we are migrating means I will explain you with one example also. Then you will get to know very easily. This is the most important step in this reaction. So here R2 should be more electron rich. If it is more electron rich, then only it will migrate. See here we are considering R2 is greater than R1. Like this R2 is more electron rich than R1. So we are considering this situation. I'll explain you one example with one example. See here, let's say for example one rich person is there, one poor person is there. Poor person, so who will able to give money to others? Only rich person can give money to others, no? So here also same situation, like R2 is more rich, so it is able to migrate and it is giving electrons to this oxygen. So in this way you can remember this thing. Generally in this reaction we have the order of the migratory group. So if we remember that group, that order, we can, if it is more electron rich, then that group will be migrated. That's it. Generally in advanced exam they used to give the migratory order. In other exams we need to remember one order. I will explain you that order also. So here we will get this one oxygen, here we will get R2. R2 will be shifted towards oxygen. So here it is making R2 is making bond with oxygen. So another product will be RC double bond O minus. Here O minus will be abstract this hydrogen from this, and then you will get ester from here. R1 C double bond O R2. This is the product. See what is happening here. Here we are just inserting oxygen here. In between this carbonyl carbon C double bond O and electron rich one. So just remember like this. Here I will explain you with few examples. Then you can able to understand very easily. So let's see some examples. Here we have this MCPBA, metachloroperbenzoic acid. This is the basic reagent we have to should know. This is per acid, majorly used in this reaction. So here first I need to write the migratory order, then I'll explain this example. Let's see the migratory order of some groups. Migratory order of the groups. Here tertiary alkyl is more greater than cyclohexyl is greater than secondary alkyl. This is the general order. It's not like you can do by that concept itself, like which is more electron rich, then you can insert the oxygen in between carbonyl carbon and that electron rich center, or else you can remember this order also for basic understanding. and benzyl. Benzyl is more similar to phenyl, and then vinyl group, and then primary alkyl, and then methyl. Now let's see this example. Here we have the CH3. It is primary carbon. This carbon is secondary carbon. So here it is more electron rich, because see here this one is there, this one is there. These are donating to this carbon, so this is becoming more electron rich. For this carbon, no one is there to donate, so it is less electron rich, you can say. So we need to insert oxygen in between this carbonyl carbon and this group. That's it about this reaction, nothing much. You can easily write the product O C double bond O CH3. Let me explain you some more examples. Let's say this is also used like if we have cyclic ketones, then those will converted into lactones. Let me explain you with one example. That one. See, if you have this ketone, we are adding H2O2 in the presence of Lewis acid, then we will get, see here these two groups are same, so you can insert here or here, wherever, both are same only. So if you insert that one, you will get the product like this. This is called lactone, this is ketone. So thank you guys, this is all about this Baeyer villiger oxidation reaction. I hope you guys understood this reaction. If you have any doubt, then let me know through comment section. I will definitely clear your doubts. And